Okay, so you want to develop device drivers and you need help, right? This is going to be a very quick guide, very straight to the point. So basically, the first thing you should always do when you're programming a driver is to always start reading the data sheet on the driver, right? So in this case, I'm using the BMM 350 magnetometer for our rocket, right? So first, I'm always going to look at the data sheet, see how exactly this thing works, and see the communication protocols it uses, right? So if we scroll here, it should tell us relatively early what communication protocol it is using, and it's using I squared C. And what communication protocols are, it's how the data from the sensor is actually transmitted to our microcontroller so that way we can read it and do stuff with it, right? So in this case, it's either going to be I squared C or I cubed C. We're going to use I squared C, or at least I use I squared C when creating my driver because there's a lot more like legacy behind it. It's a lot more widely used. It's a lot easier to deal with compared to I cubed C. I mean, I cubed C is improved, but like we want to stick to the basics, right? But the main thing is you always want to read your data sheet because it'll tell you exactly how this works, exactly like what registers you need, because that's another important thing. You want to be able to read your register map because you do have to define it here as shown. And it'll just tell you what the sensor can be used for, right? So then the second thing, which I always recommend you do, is to think about what you're using the sensor for. What am I gonna use this, like what data am I gonna take from this sensor, right? Like, why am I using this? And if you think about that, it'll make it so much easier to think of what functions you need, right? So I was thinking about it myself for this sensor, and all we really need is to calculate the magnetic field like at a specific point, right? So knowing that, what I did is I looked for the data sheet to see where I can find my magnetic field, right? And if we go to our table of contents, it's pretty easy to find. This entire part here, I know you can't see it. I'm not sure if you can see my mouse, but this entire part here corresponds to the magnetic field at the magnetic field vector right here. So just by looking at the data sheet and knowing what like I'm looking for, I can super easily find what I need, right? And then knowing actually what you want to use it for will make figuring out what functions you need so much easier, right? You have your initialization function, you have your read register function, because you want to read the registers here for the data for the magnetic field vectors. You have your get status to see, okay, what's going on with the sensor right now. Your get data function, which returns the data from these registers. And then you have combine access data, which I just use as a helper here. But you get the point, right? Knowing what exactly you want to use the sensor for make it so much easier, right? Because like for example, earlier when I was programming the ADC, it's not in this branch, there was a function on it which would allow me to get the gain, I'm pretty sure. But like I don't want to use an analog to digital converter for the gain. I just want to convert analog signals to digital signals. So I completely disregarded that. It's the same thing here. This this sensor gets the temperature, right? But I'm not using it to get the temperature. I'm using it to get the magnetic field. So that's why I only have this. It allows us to make much leaner and memory like more memory mindful. It allows us to be more mindful with our memory because we're only using it for what we actually need. And if we do end up coding too much, then we're kind of wasting our time because we just code something that we don't even need to use into like it just doesn't make sense, right? So it's always good to know what you need and then just mm, do it like that, right? And for the last thing, this is mostly applicable to when you don't have the hardware on you, is to always abstract the protocols, the data protocols, whenever you don't have hardware. Now, what do I mean by abstracting it? What I mean by that is basically how these protocols are handled with most microcontrollers is that they have a hardware abstraction layer, which will allow you to easily interact with the microcontroller without having to program something entirely new, just so you can interact with these data protocols, right? It's like an API basically. So since I don't know what board I'm using, I don't know what STM function to use here, right? So obviously, I'm just going to create a macro and then have it equal to something random. For this case, it's just returning 0 no matter what I put in here. And what that actually allows me to do is that allows me to not worry about having to get the data protocols to work because I could just put them in my functions. And they're always going to return true so that I don't have to worry about it, right? And that makes creating drivers so much easier because if you don't have hardware, there's no point in programming or like adding these communication protocols because you can't even test them yet. So it makes so much more sense. It's so much more efficient if you just create a macro for it, leave it be until you actually have hardware. And then one thing I like to do whenever I make drivers, I like to make it so that when you make your functions, I always like to return as an 8-bit integer. And the reason I like to do this is because I like to have specific error codes based on the function error, right? Based on which function has an error. So I have a struct which gives me each different type of error, right? So that way, if something goes wrong, it's super easy to debug. So like, say if my function returns error -4, oh, there's a problem with my get data function. So I just go to my get data function and see what's going on here. Oh, the data pointer is null. That's why I'm getting an error get data function. Oh, if the combined access data thing check here doesn't work, oh, then I'll get the get error for the data, and then maybe I'll go check my combined access function, stuff like that. And that makes it so much easier to debug when you actually try and implement the hardware, and it's just a lifesaver. And that's basically it. Those are my 3 tips. So you want to always read the data sheet. Think to yourself, what am I actually using the sensor for? And just abstract all communication protocols if you don't have hardware. And that will make it so much easier to create drivers extremely fast. Like I created these in a matter of few hours just by following these tips, right? And that's it. I hope you have fun creating your own drivers because, like, right now I'm the only one making them, or I'm gonna be the only one making them next year. So I might need some help.